Welcome to Oil Spill Response Training. In this course, you'll learn how oil spills occur, the environmental impacts they create, and the methods used to contain, recover, and clean up spilled oil in a variety of environments. Oil spills into rivers, bays, and oceans are typically caused by accidents involving tankers, barges, pipelines, refineries, and storage facilities. These incidents often occur while oil is being transported and can result from severe weather, equipment failure, or navigation errors that lead to collisions, explosions, or fires. Oil spills can happen for many reasons, including human error, equipment failure, natural disasters such as hurricanes, or even deliberate acts. Once released, oil usually floats on water and spreads quickly across the surface, forming a slick that becomes thinner over time until it creates a rainbow-like sheen. Oil spills can have serious impacts on wildlife and ecosystems. Oil damages the insulating properties of fur and feathers, exposing animals to harsh conditions, and can also be ingested during grooming, leading to poisoning. Depending on the size and location of a spill, large numbers of birds and marine animals can be injured or killed. Responding to oil spills requires coordination between government agencies, private companies, scientific teams, and volunteers. A wide range of tools may be used, including booms, skimmers, sorbents, dispersants, in-situ burning, vacuum systems, and heavy equipment to contain and remove oil from water and shorelines. Different cleanup methods are used depending on the type of shoreline and the characteristics of the oil. Some environments allow for mechanical cleanup, while others are too sensitive or inaccessible. In certain cases, responders may decide that taking no action is the best option to avoid causing additional environmental damage. Mechanical containment and recovery are the primary methods used to respond to oil spills in the United States. Equipment such as booms, skimmers, and sorbent materials are used to capture and store oil so it can be removed and disposed of properly. Containment booms are floating barriers used to control the spread of oil on the water's surface. They help prevent contamination of shorelines and concentrate oil into thicker layers, making it easier to recover and remove. There are several types of containment booms. Fence booms have a high freeboard but are less effective in rough water. Curtain booms perform better in waves but are harder to clean and store. Inflatable booms are versatile and effective in rough seas but are more expensive and can be damaged easily. The effectiveness of booms depends heavily on water conditions. Waves, wind, and currents can reduce their ability to contain oil. Booms must be monitored continuously and adjusted as conditions change to maintain their effectiveness. Boom performance is best in calm water conditions. Rough seas can lead to failure, and oversized booms may actually be more prone to damage. In general, booms are not effective when waves exceed 1 meter or currents are too strong. When standard equipment is not available, improvised booms can be created using materials such as wood, pipes, tires, or sand barriers. These temporary solutions can help contain oil until more effective equipment arrives, especially in calm or sheltered waters. Skimmers are devices used to remove oil from the water's surface. They can be operated from boats, shorelines, or as self-propelled systems. Their effectiveness depends on environmental conditions, particularly wave activity. There are 3 main types of skimmers. Weir skimmers collect oil using a barrier at the water's surface. Oleophilic skimmers use oil-attracting materials to remove oil, and suction skimmers vacuum oil into storage tanks. Each type has advantages and limitations depending on the situation. Sorbents are materials used to absorb or adsorb oil from the water. To be effective, they must attract oil while repelling water. Sorbents are often used to remove remaining traces of oil after other cleanup methods have been applied. They are commonly used for smaller spills or in areas that are difficult to reach with other equipment. After use, they must be properly disposed of or recycled according to environmental regulations. There are 3 main types of sorbents: natural organic materials, natural inorganic materials, and synthetic materials. Each type has different absorption capacities, costs, and handling requirements. Natural organic sorbents include materials like straw, sawdust, and peat moss. While they are readily available and effective, they can absorb water as well as oil and may sink, making recovery more difficult. Natural inorganic sorbents include materials such as clay and volcanic ash, which are inexpensive but not suitable for use on water surfaces. Synthetic sorbents, such as plastics and polymers, are highly effective and can absorb many times their weight in oil. When selecting sorbents, factors such as absorption rate, oil retention, and ease of application must be considered. Some materials may release oil during recovery or be difficult to apply in certain conditions, which can create additional challenges. Chemical and biological methods can be used alongside mechanical cleanup techniques. These methods help break down oil and reduce its impact on the environment, particularly in sensitive areas. Dispersants are chemicals applied to oil spills to break the oil into smaller droplets. These droplets mix into the water column and are further broken down by natural processes, reducing the amount of oil remaining on the surface. The idea behind dispersants is relatively simple. When an oil spill happens, the oil sits on top of the water. Once you add a dispersant, it attaches to the oil and starts breaking it down into droplets. The addition of motion allows the concentrated oil to dilute within the water. Dispersants work by attaching to oil and helping it disperse through wave action. This reduces the concentration of oil on the surface and lowers the risk to birds, mammals, and shoreline environments. Dispersants are most effective when applied quickly after a spill and work best with lighter oils. Environmental conditions such as temperature and salinity can affect their performance, and their use is regulated to minimize environmental risks. The use of dispersants involves trade-offs. While they reduce surface oil and protect shorelines, they may impact organisms in the water column. Decisions about their use require careful evaluation of environmental factors and potential risks. Some countries rely heavily on dispersants because rough or choppy sea conditions can make mechanical containment difficult. In the United States, dispersants have not been used as extensively due to concerns about long-term environmental effects, challenges with timely application, and differing scientific opinions on their effectiveness and toxicity. While modern dispersants are less toxic than earlier versions, their long-term cumulative environmental impacts are still not fully understood. Gelling agents, also known as solidifiers, are chemicals that react with oil to form rubber-like solids. For small spills, these chemicals can be applied manually and allowed to mix naturally, while larger spills may require high-pressure water streams to mix the agent into the oil. Once solidified, the oil can be removed using nets, skimmers, or suction equipment. However, a major limitation is that large quantities of gelling agents are often required, making them impractical for very large spills. Biological agents are materials or organisms that increase the rate of natural biodegradation. Biodegradation is the process by which microorganisms such as bacteria, fungi, and yeast break down oil into simpler substances. While this process occurs naturally, it can take years, so bioremediation techniques are used to accelerate cleanup, especially in sensitive environments like shorelines and wetlands. Two common bioremediation techniques are fertilization and seeding. Fertilization adds nutrients such as nitrogen and phosphorus to stimulate the growth of native microorganisms that break down oil. Seeding introduces additional microorganisms to increase the population of oil-degrading microbes. Both methods are designed to speed up the natural cleanup process. Physical cleanup methods are used primarily on shorelines. While natural processes like evaporation and biodegradation begin cleanup, they are often too slow to fully restore the environment. Techniques such as pressure washing, wiping with sorbents, raking, and bulldozing can help remove oil more quickly. In addition, scare tactics such as noise devices and visual deterrents may be used to keep wildlife away from contaminated areas. Preventing oil spills is the most effective way to protect the environment, but spills can still occur, making preparation and response critical. Operators of vessels, pipelines, and facilities must be ready to respond quickly using appropriate equipment and strategies. Although response efforts are influenced by environmental conditions like wind and currents, proper use of containment and recovery methods can significantly reduce damage. Advances in science and technology continue to improve our ability to respond to and minimize the impact of oil spills.